Hello students. Topic is electric current. So the flow of current is calculated by the flow or transfer of charge through the conductor. Current is charge upon time. Just we have to calculate the amount of charge for given time t. So why this charge is flowing? This is because of the flow or motion of electrons across the conductor. Normally, we will be given the number of electrons per unit volume. That is the property of the material. And we already know the charge on one electron. So, just we have to calculate the total number of electrons in a given length, or we can say the volume of the conductor. As we know the number of electrons per unit volume, so we just have to multiply it with the total volume of the conductor. That is, volume can easily be calculated by multiplying the area of cross section with the length of the conductor. Now here a new term came, which is BD, drift velocity. Now we will discuss what is this drift velocity. There are two types of velocity for the electrons. When the electron is in motion, we talk about thermal velocity. This is in the range of 10 to the power 5 meter per second. And the drift velocity is in the range of 0.1 millisecond meter per second. So definitely the thermal velocity is much greater than this drift velocity. The reason of thermal velocity is, as the name suggests, thermal means this velocity component is because of the temperature. As the temperature is raised, the energy of the electrons became more higher and this thermal velocity is increased. But as this is in random motion, so the net flow of charge because of the thermal velocity is zero. Whereas the drift velocity develops because of the effect of the electric field intensity, and this electric field intensity develops because of the applied battery or voltage across the conductor. Now we will calculate the drift velocity. For calculation of drift velocity, we first know how the electrons are drifting. Definitely the electrons have negative charge, so the motion, or we can say that they will drift opposite to the direction of electric field intensity. And what is this electric field intensity? Electric field intensity is the force a unit charge experiences when it is kept in an electric field. And here, to calculate the velocity, we will use the Newton's law of motion. And why we are using this Newton's law of motion? This answer is given in the subsequent videos. Here we will focus on this calculation of drift velocity. So the velocity comes out to be charge on one electron, electric field intensity, by m into tau. Tau is relaxation time here. That is the time taken between collision. So we have derived easily the drift velocity v, that is equation 3. Now, till now we have calculated the charge, the drift velocity. So we can easily calculate the current, as we already know the charge equation is NEA, drift velocity into time. So we get easily the current, that is NEA VD. Here N is number of electrons per unit volume, E is charge on a single electron, A is area of cross section of the conductor, and VD is drift velocity. If the current is known, simply by dividing the current by area, we get the current density. From this equation, the Ohm's law can also be easily derived. We will see how the Ohm's law can be derived by this equation of current. We know the equation of this current is NEA into drift velocity, and we have already calculated the drift velocity. So just put that drift velocity in this equation of current. And as the electron drift because of a potential across the conductor, so here a voltage V is applied. Now the current comes out to be Ne square tau by m into V by L into area of cross section of the conductor. V by L is actually electric field intensity. E is equal to V by L. Now this Ne square tau by m term is a constant. It is basically the property of the material, and this is called the conductivity of the material. So from simple calculation here, we get 1 by sigma is equal into L by A is equal to V by I, and 1 by conductivity is known as resistivity. So we get rho into L by A is equal to R. From these two equations, we easily get V is equal to IR, that is a linear relationship between voltage and current for a conductor. This is called Ohm's law.